Good morning everyone. My name is Mrudula, working as Assistant Professor in the Department of Electrical and Electronics Engineering at MLR Institute of Technology, Hyderabad. Today I am going to discuss a topic about the introduction to the PCC as well as MCC panels. These are the contents which I am going to discuss today. What is the PCC and MCC panels? MCC and PCC are the electrical panels that manage and distribute the power in industrial as well as in the commercial setups. So, MCC stands for Motor Control Center and PCC stands for Power Control Center. That means the Motor Control Center and Power Control Center are the two different types of panels which are being used in industries as well as in the commercial buildings also. First one, MCC panels. It can control as well as manage multiple motors for a single location. That means from a single location itself, we can control different types or different electrical motors. And the second thing is supply low tension LT powers to the motors. That means you can connect LT connection to the different types of motors by using a single MCC panel. It includes motor starters, circuit breakers and overload relays also. These MCC panels includes the motors, their starters, the circuit breakers which are connected to these motors and the overload relays. All these are combined, commonly used in the MCC panels. It ensures the safe and efficient motor operation. For the safe and efficient motor operation, we will be using these MCC panels. The second one is PCC panels, that is Power Control Center. This distribute as well as manage the high tension power received from the transformer or the main source. That means the power which is being received from the transformer or from the main source is being connected to this PCC panel. It has control voltage, reactive power and ensures stable power distribution. The PCC panels ensures the stable power distribution. It controls the voltage as well as the reactive power also. It includes protection relays as well as switch gears. It includes the protection relays, different types of relays as well as the different switch gear systems. It ensures the seamless operation and minimizing the potential power related issues also. So, this is the PCC panel as well as MCC panels. Here you can see the picture of a PCC panel. That is, PCC panels are used for supervise and control the power system. That means for supervising as well as for controlling the power system for large industries or for high-rise buildings. They are mostly used for large industries as well as for the high-rise buildings. These PCC panels are being used. Two numbers. Here you can see the power source are used for backup supply. Both power source are received from LT panel as well as the distribution in different outgoing sources also. That means for HT as well as for LT. For most of the industries, for large industries, we will be using the HT, but this can be used for LT panel also. For low tension, HT means high tension, LT means low tension, that is for low voltage ratings also. Here you can see a simple connection diagram which is being connected to the LT panel. the LT panel is being connected to two sources, that is the source 1 as well as the source 2. The source 1 is connected to ACB, that is air circuit breaker, and source 2 is connected to another air circuit breaker for switching purposes, which is connected to a bus bar here. The first source, in addition to this ACB, is being connected to the bus bar, and this bus bar is again connected to two circuit breakers. From the first circuit breaker, tower A is being connected, which is being connected to three different floors, that is 1, 2 and 3, and this is connected to tower B. Here also it is connected to the floors 1, 2 as well as 3, and there is a small connection between, there is a small switch between the bus bar here. That means the source 1 and source 2 are being connected here in this bus bar by using a switch. So when source 1 is shut down, from source 2 also we can take the power by using this switch. So for emergency purpose, this switch is being connected here. This also is having the two ACBs, that is ACB 1 as well as 2, which are being connected to tower 1 as well as tower A as well as tower B for the floors 1, 2 and 3. So this is a small diagrammatical representation of a PCC panel. What are the components which are being used in the PCC panel? The first one is metering section. The measuring meters are being used to measure the simple system parameters like the voltmeter, ammeter, multifunction meter and etc. Voltmeter for measuring the voltage, ammeter for measuring the current, and multifunction meter, which can measure the frequency, voltage, current, etc. So the first one is measuring meters. Many types of meters are being used in panel as analog meters as well as digital meters. That means these measuring meters can be of two types, analog as well as digital. The ammeter and voltmeter and multimeter and energy meter are being used for measuring the different parameters. It can be used as analog as well as digital based on the requirement. The second type is indicators. Different types of indicators. Indicators are being used for knowing the status of the panel operation. It is used for knowing the status of the panel operation. Different types of indicators are being used with different colors. The first one is R phase, Y phase, B phase, that is 3 phases. For 3-phase connection, you will be having R, Y, B. For breaker in the on state, off state or in the tripping state also. So these are the different indicators which are being used. This third one is selector switches. Third one is selector switches, that is ampere selection switch as well as voltage selection switch and the TNC switch for selecting the voltage or current or any other thing. The second one is the supply incomer selection. That is, 2 number of supply source incomers are being available and connected with the bus bar. In the previous diagram, you can see there are 2 sources, that is source 1 as well as source 2. So 2 sources are being connected with the bus bar. If the supply from this one source has a problem, as I said previously, if the source 1 is having any problem, they can take the supply from the second source. So both the sources, source 1 as well as source 2, are being connected to the bus bar using the help of a bus coupler. The switch which is being placed, this switch is nothing but the bus coupler. So by using the bus coupler, we can connect both the sources to the bus bar. The next one is outgoing feeder section. The outgoing feeder are used for distributing power supply like a high rise tower 1 or the high rise tower 2, etc. So the tower A or tower B or tower C can be connected here using this outgoing feeder section. And air circuit breakers. Air circuit breaker is nothing but ACB. Air circuit breakers are being used for making as well as breaking, that is connecting or disconnecting the outgoing feeders. The next fourth one is bus coupler section. The bus coupler are used for eliminating the incomer source from the incomer sources each other. That means if one source is not working, the supply can be taken from the other source. So the bus coupling is being done. What are the here you can we have seen the different parts in PCC, and now these are the different parts of the MCC panel. In MCC panel we will be using the MCB, MCCB. MCB is miniature circuit breaker and MCCB is motor control circuit breaker. You will be using the contactors, the overload relays as well as the phase sequence relays, indicators, push buttons, that is to switch on as well as to off the device. The next one is metering device and many other devices. So all these devices are being used in the MCC panels. The first, here you can see the distribution system used in large commercial as well as in the industrial applications can be complex. That means when compared to the residential, the commercial as well as the industrial applications are complex. So the power may be distributed through various switchboards, transformers or through different panel boards also. The power distribution throughout a commercial as well as the industrial application is used for a variety of applications such as heating, cooling or lighting, and the motor driven machinery also. That means in these industries as well as in the commercial buildings, they will be using the power supply for heating purpose, cooling purpose, lighting purpose or for using the different types of motors. Here you can see the simple diagram of an panel. Here you can see the switchboard which is being connected to a voltage of 480 volts. By using a feeder bus bar, we are being connecting this to the panel board. This panel board is being connected to transformer as well as this transformer reduces this 480 volts to 120 volts. That means it is a step down transformer, and by reducing it to 120 volts, this is being connected to another panel board which is being connected to different small capacity loads. This switchboard is again connected to one more motor control center, that is MCC, one more motor control center. Here you can see the motor, different types of motors, motor 1 as well as motor 2 are being connected or being driven with a voltage of 480 volts. So this control panel, they are being divided into two ways. The first way is being connected to higher loads, that is motors. The second way is being connected to small loads, that is for lighting purpose. By using a transformer, we will be reducing the voltage and we will be connecting these two small loads. So the switchboard is being connected to high loads as well as low loads also. In many commercial as well as in industrial applications, few electrical motors are required, and it is often desirable to control some or all the motors from the central location itself. That means from center location itself, we need to control different motors which are being connected. So the apparatus designed for this function to control the motor is nothing but your motor control center. Motor control center means the panel which controls different motors which are being connected to the panel. So the motor control centers are simply physical groupings, are nothing but physical groupings of a combination of different starters in one assembly. That means different starters are being required to start the motor. So all these combination are being connected to the MCC. The combination starter is a single enclosure containing the motor starter and fuses or circuit breaker. That means the combination starter means it combines the starter plus fuse plus circuit breakers. Combination of starter as well as fuse as well as circuit breaker, you will call it as combination starter, which is being placed in the MCC panel. Here you can see a single small diagram where the MCC controls the whole room where different motors are being connected. What are the advantages? What are the advantages are like, it is faster and easier installation as well as wiring can be done. The centralized motor control can be done because all the motors are being connected to a single panel, and generally less total space is required. The controlling is being done from a single panel, so the space also being reduced, and attractive appearance, because the appearance also is good because all the control panels are being placed at a single place, and simplicity by adding special components such as service entrance switches, load centers and transformers. By connecting all these things, the simplicity increases, and ease for future modifications. That means in future also modifications can be done, and those modifications can be done in the single MCC panel also. So these are the different advantages. And next one is power supplies. That means the major power supply of electrical power is being used by motor control center is an AC generator. It is an AC generator which is being located in the power generating facility. In the power generating facility, AC generator is being connected, and from that AC generator, the MCC panel is being connected, and from this MCC panel, the different types of loads are being connected. And this simply means that when conductors are moved through a magnetic field, the voltage is induced in the conductors. A basic generator consists of a simple generator combination. So AC generator is there in the power generating facility. So from this generating facility, AC generator is being there. From this AC generator, the MCC panels are being supplied, and to this MCC panel, different motors with combination of fuses and circuit breakers are being connected. That means from the generating facility to AC generators, from AC generators to MCCs, and from MCCs to different loads are being connected. This is the simple three-phase supply from the AC generator, where you'll be having 3 phases, phase A, B as well as C, with a phase difference of 120 degrees. That means phase A and B, the difference is 120. B and C also 120. Here you can see difference is 120. C and A is also again 120. Here the simple diagram. Here the voltage is 480 volts between. This is the connection, star delta connection. This is the star connected. This is delta connected AC generator. This is star connected AC generator. In star connection, we will be having 4 nodes, that is A, B, C as well as neutral. In delta, we will be having 3 nodes, that is A, B and C. So here the voltage between the phase A and the phase B is 480 volts. Here you can see the voltage between phase A and phase B is 480 volts. And the voltage between phase B and neutral, this is between phase B and neutral. Phase B and neutral is 277 volts. So the voltage differs. Phase to phase voltage is 480. Phase to neutral voltage is 277 volts. A to B, B to C, C to A, A to N, B to N. These 3 are phase to phase voltages. These 3 are phase to neutral voltages. So here you can see the diagram, star as well as delta, and the different types of phase to phase as well as phase to neutral voltages from an AC generator. This is motor connection. We are connecting the AC generator to the MCC panel, and from that MCC panel we will be connecting the different motors. Different motors are mostly the inductive loads. So here is a simple diagram of an inductive 3-phase motor, where you have stator as well as rotor. This is nothing but your stator, that is a stable part, and this is a rotor which will be rotating, and this is your shaft which is connected to the rotor. And these are the power connections, that is 3-phase connections. Here you can see phase A, phase B, phase C. A, B, C. 3 phases which are being connected to the fuse and circuit breakers and then to the MCC panel. In next class, I would like to discuss about different LT breakers. Thank you.